Okay students, so now we will see some problems based on tension, that is free body diagram, and these problems are based on the pulley, using pulley. One first case we will see the vertical motion with the help of a smooth pulley, and second the horizontal motion of bodies. Now in case of vertical motion with the help of a smooth pulley, you can see that is that a pulley, obviously one end is fixed with rigid support, and a string is massless, okay, a massless and inextensible string is passed over the pulley, and with its and at its two free ends two bodies are attached, body A and body B. So obviously the body having the greater mass, it will just pull down, and the body having the less mass, it will just move in the upward direction. And since the the pulley is smooth and the string is massless and inextensible, so it will produce, okay, uniform acceleration in both the bodies. Suppose you can see in the diagram, in this end body A is suspended, and towards the right side, okay, the body of B of mass capital M is suspended. Capital M indicates that the mass of body B is greater than that of mass of body A. So that's why the mass of A is indicated by small m, and that of B is capital M, and M is greater than M. So obviously the body B will just pull down in the downward direction, and A will pull down. Since then it will produce same acceleration. With this acceleration, with acceleration A, body A will move in the upward direction, and B with the same acceleration it will just move in the downward direction. So now we will consider the motion of A. Now first of all, considering the motion of A, we will write using Newton's second law, that is, now since the body A is ultimately moving in the upward direction, its mass is m, small m, so its weight always acts in the downward direction. So weights acts in the downward direction, tension in the upward direction. But in spite of resultantly net at the end of the day, it is moving in the upward direction. It means the tension force is greater than that of its weight. So that's why resultant force acting on it is T minus mg. If the body would move in the downward direction, in that case we could write mg minus T. But since ultimately it is moving in the upward direction, so obviously tension T, the effect of T is greater than that of mg. So T minus mg. So this is the resultant force equals to its acceleration is equal to force. So force is equal to mass into acceleration. This is equation number 1. Now considering the motion of body B. Now here the body B is moving in the downward direction. Its mass is capital M, weight mg is acting in the downward direction, tension T. So now since the body B is moving in the downward direction, it means here the effect of its weight is greater than that of T. It means weight mg is overcoming tension T. So here you can see A capital M into G minus T is equals to its resultant force, that is M into A. So from 1 and 2, comparing the value of the tension, from 1 we can get T is equal to mg plus ma. You can see is equal to, now T is equal to m into, moving T towards the right side and left side, mg minus ma, or A is common, small m plus capital M, that is A, ma plus ma, we are shifting ma towards the left side, okay, and G is towards the right side. So minus ma will be plus ma. So taking common, A is equal to small m plus capital M equals to taking G common, capital M minus small m. So from this we can get the value of the acceleration of the system, of the two body system, that is capital M minus m by m plus m. Now in so many books it is written m1, m2, whatsoever. Always remember in this case capital M means the first m, that is the heavier body minus lower, heavy mass minus lower mass. In the denominator is very easy, sum of the two masses, no confusion. But in the upper is very easy, that is heavy mass minus less mass, clear, into G. Now we will try to find the value of the tension. Now from 1 we will just substitute the value of A. Now putting the value of A, we can clearly get the value of T by calculating, that is twice mg divided by m plus m into G. Remember, the very easy trick to remember. Now these are applicable in case of numericals. When we will solve numericals, it will be okay. We will use this formula as only based on the numericals, clear? So in the denominator you can see both are equal, that is in case of acceleration and tension, that is m plus m, g, g. Only the difference is in case of acceleration, heavy mass minus lower mass, heavy mass minus less mass, and in case of tension, double in the product of the two masses. Very clear. You have to practice this. Now we will see the horizontal motion using this pulley. Now in this system, okay, here both the bodies are moving, one in the downward direction, one in the pulling in the upward direction. But here suppose this is a smooth table, one body is placed in the smooth frictionless table, and again one body A is fixed. Okay, it is fixed, and with one end a frictionless, okay, a smooth and copy, a smooth pulley is attached here, and another body is suspended on the free end, and due to this, okay, a horizontal motion has been created in the body A. To create a horizontal motion, that is horizontal motion using pulley, okay, though B executes linear motion, okay, but here in this case using the smooth pulley and suspended on the free end a particle B, a horizontal motion of which of body A horizontal smooth, okay, a horizontal motion is created, is produced on body A, which is fixed on a smooth frictionless table using a smooth pulley system by suspending another object on its free end. So clear? So now considering the motion of A again. Now since here you can see the motion of body A is small m, okay. Now since its weight is acts in the downward direction, it is at rest, okay, and its reactional force acts in the upward direction. So since two forces are equal and opposite, so that's why they cancel each other. But since B is moving, due to weight of the B, it is pulling the body in the horizontal direction, so that's why an acceleration is created, and again same acceleration, the force by which B is moving in the downward direction, with that acceleration A will move in the horizontal direction, so that's why acceleration is same as we saw in previous case. So now body A is moving ultimately is moving in the right side, so T equals to mg, tension, because mg cancels are no effect, only case of T is acting in this direction, so A is also in this direction, so T is the resultant force which causes the generation of this acceleration, so T is equal to ma and F is equal to mf, clearly. Now considering the motion of B, tension acts in the upward direction, its mass is capital M, its weight acts in the downward direction with acceleration A. So ultimately since it is moving in the downward direction, so resultant effect is in the downward direction. So mg minus T is equal to capital M into A. So from 1, so if we put the value of T in 2, we can get that is mg minus putting ma. Okay, putting the value of ma is equal to mg. Now calculating, we can get the value of the acceleration. A is equal to capital mg by capital M plus small m. Again, the denominator is always same. Now putting the value of A in the first equation, we can clearly get the value of the tension. So this is the expression of acceleration and tension of a free body diagram, one in case of vertical motion and one in case of horizontal motion. All these will be feasible and useful only in numericals. There will be some numericals based on this system. So it is very useful and very important, okay, very important to remember the expression of both acceleration and tension in both the cases.